Hi, my name is Scott Simpson, and today we'll be talking about the auto-ionization of water. So water is a solvent that can actually ionize itself. So let's get into a little bit what I mean by that. So if we take two water molecules and we have them react with one another, what will end up happening is we'll form a hydronium ion and a hydroxide anion. So how does this happen? Well, what ends up happening is we know that water can behave both as an acid and a base. And we know that oxygen has these lone pairs. So if we draw a Lewis structure of our simple water molecule, we have lone pairs that are localized up here. And we know through hydrogen bonding interactions, the hydrogen on an adjacent water molecule will be attracted to the oxygen of the original water molecule. And there's this attraction here. And what can happen is there will be a bond formed here and a bond broken here. So what ends up happening is this ends up forming a bond here, and we have that. Also, don't forget formal charge. So we can have a self-ionizing pair like that. Now, if we were to write out the equilibrium constant of the reaction I just erased, so we have 2H2O, and that goes to a hydronium ion and a hydroxide anion. So if we were to write out the equilibrium constant for this, which is called Kw. Since we exclude pure liquids and solids from the equilibrium constant, this isn't seen in the equilibrium expression. And what we're left over with is H3O plus times OH minus. And at 25 degrees K, this is equal to 1.0 times 10 to the minus 14th. Now this can be related to the pH scale. So we know if we have a pH of 7, we're at a neutral system. If we have a pH close to 0, we're at an acidic system. And if we have a pH up to 14, we have a basic system. So why does this only go up to 14? Why doesn't it go higher? Why does it only take on these discrete values? Well, it has to relate to this Kw, which I'll hopefully show you in a minute. So, we often look at pH and pOH. So what is the definition of pH and pOH? Well, all you do is you take the negative log of whatever species you're looking at. So in the case of pH, all we do is we take the negative log of our hydronium ion concentration. If we're looking at pOH, we take the negative log of our hydroxide anion concentration. So there's a neat relation between these two. What if we take the P of Kw? Well, that's equal to the negative log of 1 times 10 to the minus 14th. A neat trick with negative logs, if you just take the log value of whatever power of 10 you're raising it to, that will end up being the log value. If you take the negative log of that, it'll just be the negative of it. So what I mean by this, if we just took the log value of 1 times 10 to the minus 14, we'd get negative 14. But since we have this negative value out here, that ends up making it just 14. So, how does this relate to pH and pOH? Well, if we take the negative log of pKw, it should actually be equal to the pH and pOH added together. So that's why on the pH scale we can only take up to discrete values of 14. because our KW only goes up to 14, or PKW only goes up to 14. So I hope I've been informative. I hope I've explained properly what the auto-ionization of water is and how we get that constant. Thank you very much and have a great day.